question. Then the next one is we want to maximize the profit. This is the profit. 300x plus 2,250y. So I want to maximize the profit. 300x and 250y. But because the actual profit is not known, I cannot draw this line. So I change to gradient form, which is negative 5 over 6x plus k over 250. The gradient is negative 5 over 6. I can draw this gradient for the objective function. This one is called the objective function. The function that you want to maximize or minimize, which can move around one, the function that can move up and down, is called the objective function. And the gradient of the objective function is always known, right? So it's 5 over 6. I'm going to draw this gradient negative 5 over 6. How? Like this. Okay, so I use vertical distance 6 units. Here I choose 6 units, not the number of squares, the units, 6 units. Then here I choose 5 units. This represents the gradient of the objective function. Then I draw the objective function. This is the one. I cannot use the full line, right? I use the dotted line. I draw the objective function, and I'm going to maximize or minimize this objective function. How to maximize or minimize this objective function? You use the first ruler. So the first ruler, you place it on the line, exactly on the line. Don't senget like that. Place it exactly on the objective function. Okay, then you use a second ruler, place it at the base of this line, of the first ruler. So I place the second ruler, which is gray color, on the base of the first ruler. Okay, after that I slide the first ruler along the second ruler. I slide the, okay, right. Now as I move the first ruler further and further away from the origin, it will hit this point, this point C first, the point C, inside the region, inside the region. I will hit the point C inside the region first. Now this will produce the minimum profit. Who want to make minimum profit? We want to do business, of course, we want to make the maximum profit, right? So in order to make the maximum profit, you push this line further away from the origin. As I move the line further and further away from the origin, you look at the value of K. Here, the value of K is here. You look at the value of K here, right? And you see that the value of K increases on now 13,000. Furthermore, 14,000, 15,000, further away, 18,000. Here, 20,000. Now, can go further or not? Can, because it's still inside the yellow region, the shaded region. So I push it to the furthest, and the furthest is at the point A. And the profit is around 21,000, 20,900. Now, to be exact, I have to substitute the point inside the objective function. The maximum point, the point which is furthest away from the origin, inside the shaded region, is 2060. So I take this maximum point 2060, move here, maximum point 2060, I substitute inside the objective function. So it becomes 300 times 20 plus 250 times 60. So the answer is 21,000, exactly 21,000. So I have to know how to find the maximum point. the maximum point comes from the objective function, from the moving objective function. All right, we move it until the furthest away, that will be the maximum point. Use that point, substitute into the objective function, you will get the maximum value. But if you want to find minimum value, then you substitute the minimum point, right? So but you must know how to do this on the graph paper. I have shown you 2 videos how to do it on the graph paper. You refer to my video, the earlier video I posted in the group there. That is how you draw it on the graph paper. Here I show you on the computer how to do it. Any questions so far? Any question? Can understand? Can follow or not? Need to repeat? No question. Can understand? Need to repeat or not? No need to repeat. No need to repeat, then we go on